Okay, I think we're getting started. Hi, everyone. So it's Thursday afternoon. You've probably heard the term service mesh about 1 million times by now and are getting really, really sick of it, so I feel you. You probably see the Linkerd logo up here. Linkerd is a service mesh. This is not a service mesh talk, and I'm going to stop saying the word service mesh now. This is actually a talk about Prometheus. So who here has used or is using Prometheus? Yeah, a lot of people. That's what I thought. And then of you, how many of you have heard the words unbounded cardinality? A few. OK. And probably more than you realize once I kind of give the definition. So my name is Alex. I'm a software engineer at Buoyant. I work on Linkerd. I'm one of the maintainers. And like I said, this isn't actually a Linkerd talk, but I'm going to be using Linkerd as an example. And I'm going to show you how Linkerd, which uses Prometheus very heavily, ran into a lot of problems and how we worked around those and how you can kind of use those same ideas in your usage of Prometheus. So I'm going to talk about this idea of unbounded cardinality, and I'll explain what that is and explain how we ran into that with Linkerd and kind of what we did from there. So Prometheus is an open source project. It is a CNCF graduated project. It's very popular. It's very powerful. And it's very, very cool. And I would describe it as a time series database. So this means that you can store metrics in it, but you can store them at different times. So rather than just having one value for your metric, you'll be able to see a different value for different time points. And rather than just ask, what is the value of this metric right now, you can also ask historical questions. So you can say, what is the value, or what was the value at 2 o'clock this morning? Or what has the change been since last week? Or does the current value deviate from the historical norm? And so this is very useful for serving as metrics for your services or your applications, because you can monitor it, you can feed it into your dashboards, you can see graphs, you can set up alerts on these metrics, and you can kind of see it in historical context and see the time series. So it's really, really valuable for that kind of thing. So the way this works is that all your application has to do to participate in this is it has to serve this /metrics endpoint. So this is an HTTP endpoint that your application has to provide. And then all it does is gives a list. All you have to do is give a list of metrics and their values. So in this example, we have one metric. It's called request total, and it might represent how many requests your application has received in total. And this says that the current value is 17. And what Prometheus will do is it will make requests to this endpoint on a regular basis, and it's called scraping. So it will scrape that every minute or every 10 seconds or whatever interval you configure, and it'll read that value and say, OK, now the value is 17. Next time it reads it, it might be 18. Next time it reads it, it might be 19. And it keeps those data in a time series. And it does this to all the pods in your cluster. And this is really interesting because now suddenly you can, when you're querying Prometheus, you can query those pods individually. You can say, hey, Prometheus, tell me about the time series data for this pod. But you can also ask questions in aggregate. So you can say, actually, tell me about the total across all pods, or tell me about the total across these specific pods. And you can kind of roll up that data in all kinds of different ways and aggregate it together, which is really, really powerful. Things get even more interesting when you add labels. So Prometheus supports this idea of labels, that on top of these metrics, you can add key value pairs. So in this case, we have a label called method, which represents which HTTP method these requests are. And then rather than having one total for all the requests, we break it down. And we can say here in this case, we have 10 requests, which were gets, and we have 7 requests, which were posts. And Prometheus actually will read both of those values that you serve and keep them as separate time series. So there's actually 2 time series here being kept independently rather than one. And now you have the flexibility when you query this to say, please tell me only about the gets, and you can get that data, or please tell me about the posts, and you'll get that data, or you can leave off the label specifier, and then Prometheus will aggregate those together, and you can get that total of 17 kind of reconstituted out of these two time series. And of course, you can have more than one label, but maybe what you can see happening here is that there starts to be this explosion of combinations. So when we add a second label here, which is status, status has two values, in this case, 200 and 404. Now we have two different methods, two different statuses, which means there's 4 different time series. The two are multiplied together, so you have all the different combinations. So you have get with 200, you've got post with 200, get with 404, and post with 404. And so now we're exposing 4 different time series for Prometheus to track. And as you might imagine, as you add more labels and more labels and more labels and more values and more values and more values, this can really, really explode. So the total number of time series you have is the multiplication, the product of all the different numbers of values for each different label. So if your first label has 10 different values, and your second label has 10 different values, and your third label has 10 different values, that's 1,000 different time series right there. So this can blow up very, very, very quickly. But thankfully, Prometheus is awesome. And a single Prometheus instance can handle millions of time series, millions, depending on how it's tuned and configured. But it can handle an incredibly large number. So, for quite a while, until the number of labels you have, or the number of metrics, or the number of values that your labels can have really gets too large, Prometheus has no problem. And as long as you can kind of keep these values under control and make sure they don't get too large, you're not going to run into any problems, and Prometheus can easily handle it. It's really, really powerful. But just to get you a sense of how quickly you can get to 1 million, if you have 6 different labels and they have 10 values each, that's 1 million right there. So you really need to be careful and keep kind of a close eye on how many different values your labels can take and how many different labels you add. So you want to avoid both adding too many labels, and you also want to avoid labels with high cardinality. And cardinality means the number of different values that a label can take. So I warned you about high cardinality, but there's something even worse than high cardinality, and that is unbounded cardinality. These are the 2 scariest words to anyone who's kind of setting up Prometheus like this. So here's a question. What happens if we add a label for path? This seems like a really natural thing you would want to do, right? You want to be able to slice your metrics down by HTTP request path, because you want to know how much traffic is going to this path, how much traffic is going to this path, which different routes of my service are being accessed, and what's the relative traffic. This is really, really valuable and a really, really natural thing to do. But the problem here is that path label value comes from the request. It comes from the outside world, which means effectively it comes from the user, right? It's completely unsanitized user input. And as soon as you're doing anything with unsanitized user input, you should be very, very scared. So in this case, we're just taking that unsanitized user input and using it as the value of a label, which means that label value can be anything. It can be anything the user provides. It can be /A, B, C, D. And so it's very easy for this to just completely explode. Anyone can hit your application with an arbitrary path and create arbitrary new time series in Prometheus and take the whole thing down. So this is not good. But the solution is pretty obvious, right? What are you going to do if you don't want to have unsanitized user input? Well, you should sanitize it. And so you can do things like have a whitelist of paths that you would accept, and either block everything else or just bucket all of that into an unknown label value. So you are only taking a known number of different values. So if you have 10 different routes that you are aware of, you can just specify what those are, and anything else should be recorded as default or unknown or unclassified. And that way you keep your cardinality under control, and you're also not just taking arbitrary user data and putting it in your label values. But there's another problem that you may run into here. Even if you're kind of sanitizing your data and you're not letting users put in arbitrary things, you can still run into problems with cardinality. So in this example, we have all of these different paths that are coming in. So we've got books/51.json, books/52.json, 53, 54. And this is really common, right? You often have things like IDs or usernames or GUIDs or something like that in the path. And this is not bad. This is not malicious user input. This is like people legitimately using your application correctly. You have these things in your paths for a reason. That's how they're structured. But number one, this is again going to blow up your Prometheus because you have an unbounded, potentially, number of time series that you're tracking here. And number two, it doesn't even make sense to split the data out like this. Like, you don't care that you have one request to books 52. You want that all aggregated together. You want to know this is really logically one route, and you want to keep track of that count for that logical route rather than keeping these individual counts on these particular values that are not necessarily meaningful on their own. So we want some way to kind of roll that up in a way that's logical and can help us deal with, first of all, the explosion of cardinality, but also help us do this in a way that is useful to us. So this brings us to Linkerd. Linkerd is an open source sandwich mash, and it's a CNCF project. It is a really cool project. I hope you've all heard of it or checked out the booth. It runs as a sidecar proxy alongside your application. And the long and short of how it interacts with Prometheus is that it exposes that metrics endpoint for you. So because it's a proxy and it takes all of your traffic through the proxy, it's able to record all of this data about your requests. Count how many went through, how many are successes, what are the latencies of those requests, and exposes those as Prometheus metrics so your application doesn't have to do that manually. And so you get a situation like this, right? Rather than having your application expose that /metrics endpoint, you have this sidecar proxy that sits alongside and exposes it for you. But we have this problem, right? We want to be able to expose path-based metrics. They're very valuable. They're very useful. They help you understand your application. But we have the pesky path parameter problem, right? When you have a path parameter, like the ID or the GUID or whatever it is that's in that path, you have this explosion of cardinality that you can't keep track of. So what we want to do is we want to consolidate those somehow. We want to group them together in a logical way so that you get stats on the things you care about and you have a reasonable number of them. And so we kind of thought a lot about different ways we could do this, right? We thought about maybe using some kind of heuristic in order to consolidate those paths. Maybe if we saw that certain path segments had high cardinality but the rest didn't, then we would know to group those together and wildcard out the segment that was, had many different values, or maybe we can use machine learning somehow. But the more we kind of went down this route, the more we realized that there's all these different edge cases that we're never going to handle properly. And really, every application is different and doesn't necessarily want to aggregate paths the same way. So ultimately, we think the best thing to do here is to put control back in the operator's hand, back in the user's hand, and say only the person who is developing this application or operating this application really knows how the best way to consolidate these paths is. And so that brought us to the idea of service profiles. And service profiles are, all they are is a custom resource definition in Kubernetes that lets you define metadata about services. And Linkerd will read that metadata and behave accordingly. And so there's lots of different metadata that you can store in a service profile that's really useful. But I think the key one in this case is the list of routes. And a route is just what we've been talking about. It's a logical grouping of paths. And it's usually defined by a regular expression. So this is what a route might look like. It's got a name. So in this case, the name is getBooksID.json. And this is just any identifier that lets you logically name that route. In this case, we define an HTTP method. So this is for gets. And then just a regular expression. So we say that this route should match anything that looks like books and then a number .json. And any request that has a path that satisfies those conditions is going to be part of this route. And it will get that route name as its label value. So rather than having this explosion of different label values, now the label values are constrained to just being these path names. And all the requests that satisfy the conditions for that path will get grouped together. And this really puts control back kind of in your hands and lets you roll up your routes in any way that makes sense to you. And of course, you can define a whole list of these, right? So here is a list of 4 different routes. And what's really important here, and what's really key, is that this is a fixed, finite, static, known, enumerable list, right? It's not something that's dynamically generated at runtime based on the traffic coming in. This is four routes, which means your Prometheus label for route will have 4 different values. And only 4. You're never going to have that unbounded explosion. No matter what traffic comes in, it's always going to associate those requests to one of these 4, or maybe 5 if you include the default different values. So the routes are enumerable. That's how many there are, however many you define. They're user defined, and they define these kind of collections of paths. Service profiles, like I said, can define a lot of other things too. Interesting metadata about your services that Linkerd will act on. So for example, you can specify that certain routes are retriable, in which case Linkerd will know it's safe to do automatic retries on those if they don't have side effects, for example. You can give timeouts, which will tell Linkerd to time out those requests after they've been ongoing for a certain amount of, for a certain duration. And very soon you'll be able to specify things like traffic splits to say, well, when you send to this service, actually send 60% of the traffic over here and 40% of the traffic over there. It's really useful for doing things like canaries or blue-green deploys or experiments. So I think, hopefully this is all really unsurprising, right? When I tell you, well, how do you deal with this huge unbounded number of different values? The answer is, I hope kind of obvious, right? Well, you have to bucket those down to a finite number or to a fixed, known, reasonable number. But I think it's worth kind of calling it out as a pattern, because this is something that can happen not just for paths like we explored here, but for any kind of metric where there's either an unbounded or very large cardinality of values. You really need to be thinking of that, be aware of that, and kind of recognize that that's an opportunity to use this pattern to define a small known set of buckets to collect those data down to, so that you don't have this huge cardinality explosion of time series. So Prometheus is awesome. It can handle millions of time series, which is amazing and incredibly powerful. But you have to be very careful, because you can get to 1 million very, very quickly, especially when you have these values with high cardinalities. So just be aware of your label cardinality. Don't accept unsanitized user input in labels or in anything. And if you've got any labels that have high cardinality values, just group them down into a finite number of buckets. Like I said, I work on Linkerd. I'm one of the maintainers. I didn't talk too much about Linkerd here, but I am very happy to talk about Linkerd at great length. So if you want to talk about Linkerd or about sandwich mashes in general, come to the Linkerd booth or find me after, and I'm always happy to talk about that stuff. Thank you. We have time for questions. Yeah.
So just generally about service profiles, I mean, this particular usage is great, I understand that. Just generally about service profiles, would I be correct in assuming that if you want to change some of the metadata, you have to redeploy the service so that you can update the CRD, or can that be updated dynamically, any of the metadata that I have in the CRD?
Yeah, that's a great question. So the question is, if you change the metadata in a CRD, in a service profile, is that dynamically reloaded, or do you have to restart the service mesh? And it's dynamically loaded. So the way this works is that Linkerd keeps a watch on one of the control plane services called the destination service. And that service keeps a watch on the CRD. Those are gRPC watches. So as soon as the metadata in the CRD changes, that propagates immediately without restart. And Linkerd updates its behavior according to whatever is in the service profile. Yeah.
What happens to the requests which don't match any of the paths defined in profile?
Yeah, so the question is what happens to paths that don't match any of the defined routes? So there's always a default route. So I said, there's 4 routes here. Actually, there's 5 if you count the default route. So if a request doesn't match any of the specified configured routes, it'll fall back to a route that's just called default and has the default behavior. Yeah.
You also have something like variables, because we saw examples with gets and puts, but can it just be one rule that captures both?
Yeah, so the question is, can you have a route that captures both gets and puts? And yeah, so the definitions we saw for routes were very simple. They were just a method and a regular expression. But these can actually be more complex too. You can have ands and ors and group these together. You can have multiple different routes that multiple different methods that you accept on a single route. There's actually quite a bit of flexibility there. Yeah. Mm-hmm.
Is it possible to tell Linkerd where to fetch it automatically? If you have a service that exposes its API spec to an endpoint, can you tell the sandwich mesh, hey, you can get your service profile at that URL?
Yeah, that's a great question. OK, so the question is, if your service already exposes a Swagger spec or an Open API spec, can you have Linkerd read that directly rather than using a service profile? That's not how it works today. This Linkerd will always read the CRD, the service profile CRD. It's certainly possible to have kind of tooling on top that will watch the Swagger specs and convert those to the CRD and kind of update those as they change. But Linkerd keeps the CRD as kind of the original source of truth, and you would need some other layer on top of that to update that if the Swagger file changes. Yeah.
Is there any toolset that might help me to generate these paths? Because as an infrastructure engineer, I don't necessarily have idea what set of paths particular application supports.
Yeah, I really like that question. So the question is there anything that can help you generate these service profiles or these lists of paths when you don't necessarily know what they might be ahead of time? And there are a few different things you can do here. So one was just brought up. If you have a Open API or Swagger definition for your service, Linkerd has a tool that will convert that into a service profile. We have the same thing for protobuf. So if you're using gRPC, there's a tool that will convert your protobuf file into a service profile. The other thing which I think is really cool is that this integrates with Linkerd's tap feature. So Linkerd has this feature called tap, where you can watch a request stream and see the request metadata as it's flowing through that stream. You can kind of tap in like a wiretap and see what's going on there. You can actually feed that in to the service profile generation. So you can tell Linkerd, watch this request stream, watch all the paths that are coming through, and then build a service profile based on those paths, which is really cool. And then if you've got path parameters here, you may see a large number of different routes, and you would need to kind of edit that manually to collapse those down. But it should be pretty easy to do once you can kind of see what's there. Any other questions? All right. Well, thank you very much. And #SandwichMash.